Hello everyone again. So this is the problem number 3. So in this problem the question is that we have the similar problem to problem number 2 here, but instead of the 30 samples we have one sample with 25 voltmeters, and the average of them is 11.234 volts. And then the question says that if the standard deviation is given, find the population mean. So if you remember, in the previous problem we had the sample 1, sample 2, sample 3 up to sample 30, but now we have only one sample, so there is only sample 1 is 1. So the question says that for this sample determine the the population mean according to this sample, and then it gives that the x bar of this sample, the average value is that 11.234 volts, and the standard deviation here is also, it should be s and then x, it is 0.274 volts. As you can notice, it is not sx bar but is sx because we don't have lots of samples. We have only one sample, which is just the sample 1, therefore we just put the sx. The x is the sample values here. So the question says that the estimated population mean with this interval, and then with this interval, compare them. So let me just first start with the 95% confidence interval. And then for this one, I will use the formula that I had in previous slides, that the population mean will be equal to x bar plus minus the t distribution. So t distribution is very similar to normal distribution, but it is used for smaller, so number of samples, and then times the s, the sx, and then divided by the square root of n. Okay, so if you remember in our previous slides, I said that if n is less than 30, so we just use the t distribution. Okay, this is exactly the similar to normal distribution, but it is only used when you have the number of sample is that less than 30, sorry. In our case it is 25, so therefore in our case it is 25, which is less than 30. Okay. So that is the the main part of the problem. So the sx, it is given the square root of n, so this will be just the square root of 25. The x value, x bar, is given. Only problem is t alpha by 2. So to find this value, we will use the Excel, and then to find t alpha by 2, we will use the Excel, and then in Excel we have the function t inverse, and this function has two inputs. One is the alpha and the other one is degree of freedom. The alpha value, if you know from previous slides, it is just 1 minus c, and in our case c is 0.95, and therefore it will be 0.05. And the degree of freedom is n minus 1. Okay, so in our case n is 25, n minus 1 will be that 24. So we will just find the value from Excel and then put it here, and then you have the population mean. The second part of the problem, which is 99%, so 99% confidence, so 99% confidence. So again we will just use the same issue, same problem, only the t alpha by 2 is different. So alpha now it will be 1 minus c, it will be 0.01. So just degree of freedom will also be n minus 1. So the same problem, only the n value, only this t alpha by 2 value is different. Okay, so let's move to Excel and then find them, and then the last part is the compare, and then we'll just do the comparison. So Excel here, so t alpha by 2. So it will be that T inverse, okay, and then the alpha value is 0.05, and then T value is 24. Sorry, M value. This is for 95%, and then we have the 99%. We will have the same issue, only this. It will be not 0.05, it will be 0.01, and then this is 99%. So if I replace the values back here for 95 and then 99, let's do that. So for 95 we had the 2.0639, and for the other case it was 2.79. Let's say that 2.80 or 7.797. Okay, this is the alpha value for the second part. So let's calculate it and then see how it looks like. So I will just pause it here, and then after calculation I will continue. So for 95%, the population mean is 11.234 plus minus 0.11, and for 99% it is 0.15. If you compare it, you can see that if you include more data, your confidence increases, which is acceptable, yes. So if you have more data, okay, and then you have more confidence, okay, and then so you can see here, because you are sure that your confidence increases because you have lots of data, and then at least it will be here. But if you decrease the range of the data, your confidence also drops. So because you are not sure with this small amount of data, is the population mean here or not. If you have lots of data, if you have lots of, you see, you are including 99% of your data, so and then your confidence is more because you have lots of data and you are sure that okay, at least it should be here. Yes, you see that the range also goes up. So that is the essence of this problem. So with this one, I think we have finished all the problems, and then thank you for watching, and then we will have the homework problems for you similar to these problems.